So let's start with a review first. Keep in mind that we drew this diagram into our notes, and we learned that we can use Avogadro's number right here, 6.02 times 10 to the 23rd, to convert from moles over to atoms or molecules, or to convert from atoms and molecules over to moles. So if we want to convert from moles to atoms, then we blank the molar amount by Avogadro's number. So if we're going from moles over to atoms, then we're going to be multiplying it. So remember, if we start with moles, then we're going to have 6.02 times 10 to the 23rd on the top of our conversion factor and 1 mole on the bottom. So we'll be multiplying by this number. So if we want to go from atoms or molecules over to moles, since we've got atoms or molecules, Avogadro's number goes on the bottom and 1 mole goes on the top, which that means then that we would be dividing the number of atoms by Avogadro's number because Avogadro's number is on the bottom here. We've also learned that there's a relationship between mass and moles. 1 mole of any material is equal to its molar mass. So we can calculate the mass of 1 mole of water by looking at its formula. There are 2 hydrogen atoms, and hydrogen has a mass of 1.01 grams per mole. So that means 1 mole of it is going to weigh 1.01 grams. But since we have 2 atoms of it, we're going to go ahead and multiply that mass by 2. And then we're also going to add the mass of oxygen, which is 16 grams per mole. So that would mean that when I add that all together, that the mass of 1 mole of water is going to weigh 18.02 grams. And so we can also use that relationship, that 1 mole is equal to 18.02 grams. We can use that to, if we're given moles, we can multiply by the molar mass. Because our conversion factor, if we're starting with moles, 1 mole will be on the bottom, molar mass will be on the top. So we'll take the moles we're given and we'll multiply by the molar mass. We can also go from grams over to moles. We can do that by using the conversion factor with the mass on the bottom. Since we're starting with grams, we don't want grams anymore, and having 1 mole on the top. So we would be taking the grams we're given and dividing by the molar mass in order to find our moles of our material. So let's try a practice problem. Let's say that we've got 52 grams of water, but we need to know how many moles would that be. So we would take the molar mass of water, which is 18 grams per mole. We'd put that on the bottom of 1 mole. Because we don't want grams anymore, we want to know how many moles that is. So we would be taking 52 and dividing it by 18, and that's going to tell us how many moles we have. So in this example, we have about 2.89 moles of water. We can also figure out how many grams we might need to get. For example, if we need to get 1.8 moles of water, we can set this up as 1 mole of water is equal to its molar mass of 18 grams in a mole. We don't want to know how many moles this is. We want to know how many grams this is. So we would be taking 1.8 times 18 over 1. So we're just going to multiply 1.8 times 18, and that means that we would need to get 32.4 grams of water. So what if a scientist wants to know how many atoms would there be in 6 moles of sodium? Well, the first step is to set up what we start with. We're beginning with 6 moles of a material. Since we're given moles, we're going to be putting the unit of moles on the bottom, and we're going to put the unit we want to find on the top. Since we are going to put moles on the bottom, that will cancel out, and we want to know how many atoms that would be. Well, we have a relationship that we know between atoms and moles. We know the relationship that 1 mole is equal to Avogadro's number, 6.02 times 10 to the 23rd atoms. So we can simply go ahead and take these numbers and plug them in order to solve our problem here. So we know that 1 mole is equal to 6.02 times 10 to the 23rd atoms. And so what we have here is we're going to take 6 times 6.02 times 10 to the 23rd over 1 divided by 1. 1 times 1 is just 1, so we're just going to multiply this across. And if you take a minute, make sure that you put it into your calculator correctly. If you do put it in your calculator correctly, you should get the answer of 3.612 times 10 to the 24th atoms. Now, if you don't get that answer, you may be putting it in your calculator wrong, and you may want to go to the quad to check and see and learn how to make sure that you're putting it in your calculator correctly. So, you are going to need to make sure that you also remember the relationship that 1 mole is equal to the molar mass of a material. So we're going to use this often because of the fact that that's what we can actually measure in the classroom, is the mass of something. So we want to make sure that we can calculate the molar mass of something like a compound of sodium phosphate. The first thing that I want you to notice is that there are 3 sodium atoms in this compound. So that means that when we calculate the molar mass of this, we're going to actually have to do 23 grams per mole times 3 of them. Then if you notice for the phosphorus, there is just 1 of them. So the mass of phosphorus on our periodic table is about 31 grams. And then we get oxygen, but we have 4 of them. So that means that the mass of oxygen being about 16 grams, we're going to go ahead and multiply that by 4. So we're going to have to take all of this and add it all together to find the mass of 1 mole of this compound. So make sure your calculators are out and you're practicing with all these calculations as I go through them. If you add this all together, 1 mole of sodium phosphate is going to have a mass of about 164 grams. And this is very important that you are able to calculate that. Let's take a look at this next problem. How many atoms are in 6.2 moles of aluminum? Well, we know that it's asking us to find out how many atoms. So that's the question, is figure out how many atoms. We're given 6.2 moles of aluminum. Well, looking at that, I know a relationship. I know that for every 1 mole of any material, that there are 6.02 times 10 to the 23rd atoms of that material. So what I can do now is I can actually use this relationship to find out how many atoms are there if I have 6.2 moles of a material. So the common way to set this up is going to be start with what you're given, 6.2 moles of aluminum, and then put in the relationship you know. So moles of aluminum is going to go on the bottom because I don't want it anymore, because I want to cancel it out. It's what I'm starting with, so I'm putting it on the bottom here. I know that for every 1 mole of aluminum, there are 6.02 times 10 to the 23rd atoms. So what happens with this is that moles of aluminum cancels out, and I'm going to do 6.2 times 6.02 times 10 to the 23rd, and everything on my bottom is just 1, so I don't have to worry about dividing by anything. So in my calculator, I'm going to put 6.2 times 6.02 times 10 to the 23rd. Now again, you want to make sure you put this in your calculator correctly. If you don't get the same answer as me, then you want to work on learning how to use your calculator. So you should get 3.73 times 10 to the 24th atoms. If you're struggling with that calculator, make sure that you get help on being able to put these in. If you can at least get it set up, that's a good start, but we want to make sure that we're getting the right answer in our calculators. So pretty much every chemistry teacher out there will teach you to set this up as 1 mole is equal to 6.02 times 10 to the 23rd atoms. And then have you cancel out your moles so that way your answer is in atoms. There actually are a couple of different ways that you can solve this. This way is the way that most scientists, most chemistry teachers and stuff are going to teach you. I will show you another way to solve these that you might prefer if you don't like working with fractions in the way that I have here. So real quick, I'm just going to show you another way. You can set this up as what you're given over what you want to know, so you don't know your atoms. Then you can set it equal to, you know that there is 1 mole and 6.02 times 10 to the 23rd atoms. So the other way to set this up is to set up two fractions equal to each other. You're given moles, so mole goes on top. You want to know atoms, so atoms goes on the bottom. And then, if you know mathematically, you solve for x by cross multiplying. X times 1 is simply going to be x. And then you multiply 6.2 times 6.02 times 10 to the 23rd, and you get your number of atoms. So here's another practice problem for us. This time it wants to know how many atoms of tin are in 3.5 moles. So we have been given our moles, and we need to find out how many atoms that is. So if we look at our conversion factors, we have our moles, so we're right here, and we need to find out how many atoms we have. So that means we're going to take our moles given, and we're going to use Avogadro's number to convert to our atoms. So here's what our setup looks like. Remember, we don't want moles, so moles is going to go on the bottom because that's what we're given, and we want to find out how many atoms. And so we know that 1 mole is equal to 6.02 times 10 to the 23rd atoms. So we're going to multiply 6.2 times 6.02 times 10 to the 23rd, and we just have 1 on the bottom. So take a second again, make sure that you can put this into your calculator correctly, and you get the same answer that I get. So our moles cancels out. Our answer is going to be in atoms because that's what it's asking us to find, how many atoms. And if you put it in your calculator correctly, you should get 3.73 times 10 to the 24th power. And maybe you're thinking, but Ms. Vahovic, I liked the other way that you figured it out before. So 6.2 moles of aluminum, and we don't know our number of atoms. So we're going to set that equal to 1 mole is equal to 6.02 times 10 to the 23rd atoms. We want to solve for x, so we're going to do our cross multiply. X times 1 is x. 6.2 times 6.02 times 10 to the 23rd is equal to 3.73 times 10 to the 24th atoms. So we get the same answer. Let's try another one. How many atoms of tin are there in 3.5 moles? So we have moles, and we need to find atoms again. So we're going to be going from moles over to atoms. So our setup again is going to look similar. We're going to have moles of tin on the bottom. 1 mole of tin is equal to 6.02 times 10 to the 23rd atoms. So our moles cancels out. Our answer will be in atoms. And we want to make sure that, of course, we put it in our calculator correctly so that we're getting the right answer. So when we put that into our calculator, you should get 2.11 times 10 to the 24th atoms. Now, what if you're thinking, but Ms. Vahovic, I liked that other way you set it up. I'll show you that real quick. 3.5 moles. We don't know how many atoms. So we know that 1 mole is equal to 6.02 times 10 to the 23rd atoms. So if we go x times 1 is x, that means our number of atoms will be 3.5 times 6.02 times 10 to the 23rd, and we get the same answer. So the previous slides, we were practicing with using Avogadro's number. Now, what if we need to find out how many grams we have or how many grams we need to get? In that case, we're going to need to know what the molar mass of the materials are. So remember that to find the molar mass, we're going to look on the periodic table at every single element that is involved in the compound. So on the periodic table, sodium is about 23 grams, 22.99. Oxygen is 15.99. We could round to 16. Hydrogen is 1.01. So remember that in order to find the mass of 1 mole, we're going to add all of those together. And so we get 40 grams in 1 mole of sodium hydroxide. So here's how we use that. If we want to know how many moles we have, if we have 90 grams of a material, we are going to need to know the molar mass of the material. So we're going to start with what we're given. We are given 90 grams of sodium hydroxide. We want to find out how many moles we have. So since we're given grams, we're going to put grams on the bottom because we want it to cancel out. So I'm starting with grams. Grams goes on the bottom. We want to find out how many moles we have. So 1 mole is going to go on the top. And according to what we've learned, 1 mole of a material is equal to its molar mass. So 1 mole of sodium hydroxide is going to be 40 grams. So you can see that what we have here is that we've got 90 grams of our material, and we're going to divide by the 40 grams. Because remember, we multiply across, so 90 times 1 would be 90 divided by 40. So 90 divided by 40, that's going to tell us how many moles we have. So what we just did here is we went from grams and we divided by the molar mass to find out how many moles that would be. So this would be 2.25 moles. And maybe you're thinking, but Miss Vlahovic, I liked that other way that you were figuring things out, where I take what I'm given over what I don't know. I don't know my moles. Well, I know that 40 grams of NaOH is equal to 1 mole of NaOH. So then to solve for my x, I'd have to do x times 40. So I would have 40x is equal to 90 times 1, 90. So now I have to solve for my x. So you can see mathematically, we end up with the same thing, 90 divided by 40. And so that is going to be 2.25 moles. Let's do another one together. So first thing we need to know is how many grams per mole is nickel. So 1 mole of nickel, according to the periodic table, has a mass of 58.693 grams. So we're going to use that. So this time we are given 10 grams of nickel, but we want to know how many atoms are there. So we know the relationship that 58.693 grams of nickel are equal to 1 mole of nickel. So what we're doing is we're over here at grams, and we're going to have to find out how many moles we have so that then we can figure out how many atoms we have. There's not a straight path all the way over. So we're going to start with our grams, find out how many moles, and then we're going to have to do another step. So the first thing we're going to do is let's first figure out how many moles we have. So we've got 10 grams divided by 58.693 grams, and that's going to tell us how many moles we have. So when you calculate that out, you should get 0.17 moles. Now, we're going to need that because that means we figured out how many moles, but this question is asking us how many atoms. So we're going to have to use Avogadro's number next. We're going to have to do another step, another calculation to get over here. So remember that there is 6.02 times 10 to the 23rd atoms in 1 mole of nickel, okay? So we're going to use that. So we calculated before that we have 0.17 moles of nickel, but we need to find out how many atoms of nickel we have. So we're going to use Avogadro's number next to figure out how many atoms we have. So we're going to do 0.17 times 6.02 times 10 to the 23rd. My moles is going to cancel out, and it's going to tell me how many atoms I have. So I have 1.02 times 10 to the 23rd atoms of nickel if we started out with 10 grams of nickel. So that's what I started with, was 10 grams of nickel is equal to that many atoms of nickel. So if we want to go from moles to grams, we can multiply by the molar mass. Or if we want to go from grams to moles, we can divide by the molar mass. So now that we know Avogadro's number, we can go from atoms to moles or moles to atoms. Now that we know molar mass, we can go from moles to grams or grams to moles. And since we know both of these, we can actually go from grams all the way over to atoms, or we could start here at atoms and calculate all the way over to our grams. So here's another practice problem for us. We need to calculate the number of moles from 40 grams of carbon monoxide. So we know that 1 mole is equal to the molar mass of the material. So since we are given grams and we want to find moles, this is the relationship that we're going to be using. So the first thing that we have to do is we have to calculate the molar mass of carbon monoxide. So we have 1 atom of carbon with a mass of 12.01. We have 1 atom of oxygen with a mass of 16. So the molar mass, the mass of 1 mole of carbon monoxide, is going to be 28.01 grams. We are given 40 grams of carbon monoxide, but we don't want grams of carbon monoxide anymore. We want to find out how many moles we have. And we know 1 mole is equal to the molar mass. So this relationship right here, we're going to put in our conversion factor. We put grams of carbon monoxide on the bottom because we want that to cancel out. And we're going to go ahead and take our molar mass, because 1 mole is equal to that many grams. We're going to put it on the bottom. So we're going to take 40 and we're going to divide it by 28.01, and that's going to tell us how many moles of carbon monoxide we have. So there are 1.43 moles of carbon monoxide in 40 grams of carbon monoxide. So I've done a number of practice problems with you now. What I'd like you to do is pause the video and try and do these last few on your own, and then I'm going to do them very quickly on the video so that you can see if you did them correctly. So for the first one, 1.25 moles of neon times 20 grams in 1 mole means that if you've got 1.25 moles of neon, you have 25 grams of neon. Again, make sure you pause the video and try this one on your own and then check and see if you did it correctly. So we've got 3 moles of arsenic sulfide. 1 mole is 246 grams, so our moles cancels out. 3 times 246 means you'd have 738 grams of arsenic trisulfide. There's a few practice problems for you to try here. Try them on your own, pause the video, and then see if you did them right. So these are the same ones I did on the video, but hopefully you took a second to try it out and practice, and you can check all of your answers here. The best way to understand this is to practice it, and then of course, if you need some extra help, come in and see me.